Wait, if the
Well, I
globe is
mean,
a closed system, how did the astronauts went to the moon?
yeah, that means there's a physical barrier that is holding the pressurized air back from a vacuum on a globe.
Uh
I, I,
oh.
I didn't say I didn't say it was closed. You can go through the
Oh,
atmosphere.
so it's not. So the globe
So,
is
so
not
it's open.
closed. So there is no container.
Okay, so what's the container on a flat Earth?
I don't know.
The antecedent to the gas pressure?
So what is a container on a flat Earth? No one can answer this question.
An
Well, yeah, I don't
antecedent.
know. Yeah, it is
So
it is an antecedent consequent relationship, but I don't know what the nature of it is. Just like I know that you had a mom and a dad at one point. I've never seen them, so I don't know what color hair they had or what eyes they had. But I know as a consequence of you talking to me today that you must have necessarily, by deductive logic, have had a mom and a dad to parent you. Same with gas pressure and requiring a containment in order to pressurize and form a gradient.
I
I
don't
don't
think
know
that
what the
correlates.
containment mechanism is or what it looks like, but I know it's necessary
So you
that
don't have
that
data.
there's a consequence of that containment of the pressure, because pressure means pressing.
So you
A
can't.
physical barrier must be in existence somewhere.
So you can't make the opposite argument on the globe then if you don't even have any data yourself for the flat one.
Actually, NASA has X-rays, and they talk about the firmament being observed with X-rays. So you're gonna have to ask NASA about that.
What do you mean an X-ray?
I mean, X-rays. NASA doing X-rays of the sky and calling it the firmament.
That's kind of
That's
wild,
NASA
man.
for you.
I mean, an X-ray is to like see through things. So I don't know what you're really trying to get at.
That
This is
exactly.
what.
Well,
Look, here's. Oh, sorry, James.
no, go ahead.
I was just going to say, like, what we have on our side is practical demonstrations, gas laws, definitions. Right? We can demonstrate our claim that gas needs a container.
Yeah. So
The
what's the
definition
container
of gas.
on?
Yeah. We
What's
don't
the,
know exactly, but what we do know is that gas pressure. Right.
so
So
why would there not be
what
able
we
to
know
have
is what we
the
know is
same
that we
thing?
can't demonstrate gas pressure without a container. Real world, right? If you want to have gas pressure, you need a container. And the definition for gas pressure says gas pressure is the name given to the force exerted by gas particles colliding with the walls of their container. That's the definition of gas pressure, right? So we can't have gas pressure without a container as far as we can practically demonstrate.
So why
Right.
would
So
they not be able to have it
that
on
leads
a
us to
space.
that leads us to the like obvious logic that to have gas pressure you would need a container because that's
Yeah.
all we're able to prove,
But why would
we're
there
able to validate.
why would there not be able to have a container on a spherical Earth?
Okay,
Because
because
that's not part of the claim, dude.
they claim that the deep space is a vacuum, right? It's like a 10 to the negative 17 Torr vacuum. That we have a gas pressure gradient here on Earth adjacent to that vacuum without a container, right? So you can't have
Wait, who's
a
they?
gas pressure system. You can't have a high pressure system next to a vacuum because what would happen, right, is the high pressure would instantly fill the available space, right? High pressure goes to low pressure, right? And when we set up a practical demonstration where we have a gas pressure system next to a vacuum, as soon as the valve is released, that separates the two systems, the high pressure instantly equalizes with the low pressure.
So then, how do you explain wind?
Wind is caused by temperature gradients, right? Different temperatures. If you look it
that's
up,
what we were
right?
talking about.
Yeah. That's okay. So yeah, that's doesn't require a globe, right? It's just due to temperature differentials that cause that to happen. Like the other guy was reading off the official website that he was reading it off. So yeah, that's not related, really.
Right. For the globe to be true in this manner, you'd have to deny entropy laws. Because you'd have to say that gas is reversing the natural course of entropy of gases to disperse through a vacuum. And that's never been tested. It's not part of kinetic molecular theory or anything like that. It's astrophysics, it's cosmology, it's theoretical
Can
physics, and has absolutely no bearing in applied physics in reality.
I ask a question? What about magnetic confinement?
That's
Yeah.
still containment, though. That is not only containment, but you require a vacuum chamber with a barrier in order to produce it. And
Yeah,
what happens if you turn off the
it's
vacuum
vacuum
pump?
next to pressure.
What happens if you turn off the vacuum pump?
Well, no, it's the magnetic fields that's containing it.
So you're claiming the magnetic field container is the atmosphere and not gravity?
No, but I'm just saying it just has to be some sort of force.
Sure. And are you also saying this is analogous? Like a big plasma field is analogous to Earth?
It's
I mean, good luck
analogous,
NASA getting away and going to the moon.
well, in the same way that it's a magnetic field, it's a gravitational field. I mean,
No,
it
that's
is
not the same
analogous.
thing at all.
Why not?
Plasma fields are not gravitational fields.
No, but it's still a force that's applied to some pressurized system. If
Gravity's
they're
not
not
a force,
containers.
and it's not a factor in gas laws. Like I can point to every gas law and look for gravity, and it's not there. I can look for gravity in kinetic molecular theory of gases, and I can't find gravity in there either.
No,
It's
that's
negative
true.
entropy on gases, and Newton even realized this back in his day because he
Yeah, but
talked about matter being of two kinds, one that condenses into solids and liquids, and another that disperses in an anti-gravitic fashion. He didn't
yeah,
he didn't have any discussion at all about gases and gravity interacting because he knew better. But suddenly
well,
today with astrophysics, we're like, shit, there has to be gravity in gases. Well, we'll put that in the theoretical physics column and not the applied physics column.
again, okay, let me ask you this. What is a physical container?
I would say a thermodynamic boundary layer, of which gravity's not.
Well, okay, but at the end of the day, when a molecule bounces into a barrier, it is affected by force.
No
So again,
kidding. Welcome to flat Earth.
well, again, I mean, the gravitational force can also be a barrier in that way. I mean,
No,
it's just an
it's not a
exchange.
physical barrier. James Clerk Maxwell was very clear when he talked about this.
Why is it not a physical barrier though?
There's nothing physical about gravity. It's bending and warping space-time conceptually. It's a coordinate reference system that people play with and contract and expand in order to account for perceived timing differences with electrons
You
in
you don't
transit.
have you don't have to use general relativity to analyze the Earth.
No
It's not.
shit. Welcome to flat Earth. Got
Yeah, but
another one?
you could just use a gravitational field theory.
Well, you can, except it doesn't describe anything about the molecular behavior of gases. There's no molecular gravity theory or gas molecular theory. There's no there's no model that can demonstrate gravity's effect on gas either and be predictable.
Well, I agree. It's two different domains, but they can still be combined. Of
Nope.
course, there's no theory that's. I mean, it's not relevant to discuss gravity when talking about microscopic systems, which is the whole point of thermodynamics, right?
Yeah. So, what point does it scale up? For you to provide evidence that validates the claim that gravity's holding the atmosphere down.
Yeah, when masses become sufficiently large.
Yeah. When is that? I mean, at what point? At what scale is that? In order to validate the claim that gravity's even pulling gas down on Earth's
Well,
atmosphere.
okay. I mean, the truth is, we know that gravity is an extremely weak force, right?
But no,
It's like,
I would say it's not a force. That idea is about 120 years out of date.
yeah, okay. But again, you don't need to use general relativity. You don't need to
I
use that
know.
as a
Welcome to
model.
flat Earth. Got any
Yeah.
more?
No, but I'm saying it's
You
ways
you
for.
don't
I think
yeah
this would
exactly
still be
you
a
don't
circular
have to
argument with
use
them.
you don't have to use something that you cannot use. You're
You can't.
correct.
Yeah, so you can't use relativity, and you can't use Newton's theory either. So where are you left? Where are you
No,
left if you can't invoke Newton? Because Newton's gravity had no effect on gases. You have to have a surface and a radius of two objects for Newton's gravity to work. And gas molecules don't have a surface. You also have the problem of Newton describing what gas behavior is like. You can't use Newton's gravity, and you can't use relativity because it's not a force. So what are you left with? Are you bringing your own gravity to lunch?
You can have a macroscopic volume of gas, and that is still affected by Newton's laws, no?
Not gravity.
Really?
Yeah, like I just said. You want me to repeat myself?
Okay, let me ask you this then. If I go and I grab like a pressurized gas chain, like I take a bunch of pressurized gas and I bring it up to a mountain, and then I release the gas.
Wait. Did you use a container to grab the pressurized gas, or are you using gravity to bring it up to the mountain?
No, no, I put it in a container. Yes.
Oh, okay, thank you.
All right.
Yeah.
So, with that aside,
And
are
then
you
I
also
release.
conflating pressure with weight? Because they're not the same.
Yeah.
Kinetic
Okay.
molecular theory explains this too, that the mass of gases is independent of kinetic molecular behavior. It's all about thermal energy, because you can take Maxwell's equation of the velocity of a gas molecule equals 1 over the square root of mass and plug it in to the equation where the average thermal energy of a system with gas is equivalent to 0.5 times mass times volume squared. You replace, or not volume, velocity squared. You replace velocity with Maxwell-Boltzmann's equation, and you get a grand equation that cancels out mass altogether and leaves you with energy equals 0.5 is a dangling coefficient. And this proves that gas molecule behavior is mass independent. And this is reflected not only in the Boltzmann distribution, but also it's proven by Avogadro's law. Strangely enough, you get 3 containers, 3 different atomic weights of gas. And by the way, atomic weights are a different concept here. And you keep those boxes at the same temperature with the same number of moles, and it's the same pressure all the way across, whether you got hydrogen or radon. Isn't that amazing? Gases are freaking weird. Gases ignore gravity; they just fuck off, dude.
Wait. So what happens if you bring a high
Yeah,
density of gas up on a mountain? What
yeah.
happens to the gas?
Gases are anti-gravity devices.
Yeah,
No,
it's
but
weird.
what happens if you bring a bunch of gas up to a mountain?
What happens?
You release it?
What do you think about what he just said to you?
What?
The important thing was Avogadro's law. So if you have a fixed volume, say a cubic meter of container, then you have a fixed pressure. Doesn't matter what gas is inside there. If you count the number of molecules, it's going to be the same in every container, no matter what the atomic size of the molecule is. So if it's oxygen, hydrogen, helium, neon, don't matter. If you counted all the molecules in there, they're all going to be identical. It's going to be the
Right.
identical number.
So this means
That means that the mass, right? Yeah, it means that the atomic weight don't mean a fucking thing.
No, but okay, but
this is
you can
why.
still
Hold on a
pressurize.
second. If I can just say one thing to pull this home, you can see this evident in the ratio of gases at the surface all the way up to the mountaintop. It's the same ratio of molecules. You don't have pools of higher mass gases at the bottom that you're choking on, and somewhere it's like breathable halfway up the mountain, and then you get like helium at the top of the mountain, and you sound like a freaking chipmunk. It doesn't happen. Gravity would predict this, but it doesn't.
No, there are reasons for that. That's because there's way more wind and stuff that mixes everything up. Like it's the same idea with like if you have a mixture in water, it's still gonna mix. It's not gonna distribute in layers usually.
Wind is another debunk of the globe. You say wind, you debunk the globe again.
Why? Why is wind not possible in the globe? Anyways, if you bring a high density of gas on top of a mountain and you release that gas, isn't it gonna drop or no?
Depends on its temperature.
Well, isn't it okay? But I mean, if it's at the same temperature as the surrounding air.
Well, it would diffuse. They would all diffuse together.
Yeah, but on a macro scale, it would drop.
On a macro scale. No, it's just diffuse together. They'll just mix.
Yeah, and I
Really?
asked you, like, at what point does it transition? Like, do the laws of physics change between scales?
Well, okay, it doesn't. It doesn't at
It
all.
doesn't
But
change, right?
no. But the
Did you
reason.
hear dude last night saying he's going into the quantum realm, dude?
Yeah.
No, but
Or
no
quantum
model in
leap,
physics.
dude.
You realize that all models in physics are simplifications, right? So of course
Yeah,
you're always going to ignore some factors, like gravity in molecular in gas theory and stuff,
right.
because it's just not. It's just
You
not
know what
applicable.
also lets you ignore it? It not being there.
There's no scientific model for gravity.
What do you mean? Why not?
Well, because a scientific model requires experimentation and, like repeated experimentation. So where is the experiment for
Yeah.
gravity?
Where's even the scientific hypothesis that would precede said experiment?
Well, what about the Cavendish? That's not an experiment.
No.
What was the naturally observed phenomena for Cavendish?
That mass attracts mass.
Okay, when do we observe that in nature?
Well, well, I mean, you're kind of saying, okay, we observe it every day. I mean, it depends on how you view it, right? We observe it by the Earth attracting us.
Is the Earth an object with mass?
Yeah.
Okay, what is the mass of the object of the Earth and what is the shape of said object?
Well, it's a sphere and it has like 10
Okay,
to the
can you give me
24.
the measurements of the sphere, please? This is always going to go back to this. Give me the
No.
measurements of the sphere
Oh,
and how you attain
we're
them.
discussing gravity. I don't want to discuss all sorts of
Well, it's all
physics.
tied together, friend. You just claimed mass attracting mass. You're begging the question that the Earth is a mass attracting another mass. So I need to know the mass of said object and how you gained the radius of the sphere that you're claiming. Where'd you get this measurement from?
You can measure it. Well, for one, you could just take a satellite and measure it
I don't
in.
want to know what I could do. I want to know what
What
was
did they do
done,
before that?
how the data was gathered.
Yeah,
How'd they get the
okay.
satellite there without knowing the size of Earth? Like Kerbal Space Program?
Well, you just keep sending them up until something happens.
Wouldn't you
Trial and
need to
error.
I'd
know?
like to see the evidence of all the wreckage.
Yeah.
So, dude, you're you understand that Cavendish saying mass attracts mass. What's mass? What even is that?
It's resistance to acceleration. It's in Newton's second law.
Okay, so resistance to acceleration attracts resistance to acceleration.
I
Is that
thought
what
that
you're
was
saying?
Einstein's.
It is. Newton thought it was a quantity of matter, but that's not
Yeah.
important. I'll accept that because it makes it even more ridiculous.
Why is that ridiculous?
Oh, do I need to say it again? Resistance to acceleration attracts resistance to acceleration.
Yeah, I mean it's point. Well, it's points in
So
space that have that
a
property.
property causes things.
Quantum level,
Well,
huh?
you could call it points in space that have certain properties. Yeah.
That's like saying the frickin' hood ornament caused the accident. So the
No.
hood ornament is the property of the car, but it ain't the car, right? So the property of something can't be the cause of something.
Why not?
Because it it doesn't logically follow.
Yeah, an attribute is usually an expression of, right?
Yeah. Okay, but I could just say it's a point in space that has this property, and that we observe that these points in space which resist acceleration generate what do you call it? Gravitational fields.
You could say
Doesn't that
that, but
work?
then you would need an experiment to like demonstrate that.
Yeah, and
So the main problem with Cavendish is that it's not consistently repeatable.
I mean, you're right. It's a very sensitive experiment because gravity is an extremely weak force. So yeah.
Well, I mean, do you really want to, base an entire worldview on an inconsistent parlor trick?
Well, it does work. It's just very hard to
Sometimes.
get right. Well, yeah. I mean, that's the same with all experiments, though.
What do you mean get right? What is get right?
Well, it means that you've properly sort of isolated all the variables and
You mean when you
throughout the
confirm your
experiment.
bias?
No,
Is that what you mean when you confirm? Oh, like how would you know that you? How would you know that you didn't do it right?
Yeah, I mean, you could. I mean, by repeating it a lot of times.
Okay, has anybody done that? Do we got like a p-value for Cavendish to see if if the effect is better than chance?
I mean, I'm sure it's been done a lot of times. I don't know if anybody has done like a study of studies or whatever. But yeah.
Well, I mean, what you'd have to do, right? You'd have to actually set up the contraption, break it down, set it up, break it down, set it up, break it down, set it up, because you're trying to figure out the human element,
Yeah,
right? Because
I guess
that's
you're right.
that's what you want to test. How it is this a user error that's making this happen, or is it a natural phenomenon? So you have to figure out. You have to quantify the human error.
But okay, but I will say it has been done a lot of times, and you get a value very close to G.
Yeah, great, dude, but that's just confirmation bias, and that's just like
No, but
all the
okay,
data
you
that
must
I
admit,
don't like, I ignore.
no, but you must admit that's pretty remarkable, no?
No,
Really?
no,
So
it's not
you get
remarkable.
some value that makes the math work perfectly with
What
all
are you
the
talking about? They could literally add any freaking coefficient, and it would work perfectly. Everything's
no.
anti-gravity.
The value you're measuring is the coefficient.
G.
Liquid.
G is a coefficient, dude.
Yeah, exactly. So why do you measure a value that perfectly matches all sorts of predictions?
Which prediction?
Well, the movements of all the stars and the planets.
Well, they would just change the masses. If the coefficient was different. See, they got the masses from the coefficient. You understand?
I'm not sure.
They didn't have high priority knowledge of what the mass of, say, Jupiter was. They got the coefficient and said for an orbit that's this far away around the sun, it must have a mass of this with this coefficient. If they had a different coefficient, they would just say it's a different mass.
I'm pretty sure there are other ways of also getting the mass, but I'm not very knowledgeable on it, to be honest. But
I mean, I don't know how that would be. So so the whole gravity thing is an exercise in circular logic. That's the problem with it.
okay, I'm not sure that's true. But for example, I know for stars, you can by their luminescence you can estimate how much mass they have, right?
By their luminescence.
Yeah.
By their brightness.
Yeah.
Well, how did they get that?
Get what?
The mass from the brightness.
Well, you have known processes like fusion, and you know they produce a certain amount of energy per mass or something like that.
No, we don't know that. You think they're like doing fusion in the lab somewhere?
Fusion, we can study
By that logic, by that logic, you should know the mass of an UFO because you see the light flying across the sky. So you know what a UFO is then.
Actually,
By the
I
lumen.
think you might be able to tell some of its composition, sure, if you had sensitive enough instrumentation.
Are you like Ambo's little brother or twin brother or something?
Who's that? I don't know who that is.
Oh, never mind.
Are you trolling, dude?
He sounds more like bacon.
Oh yeah, bacon.
I think you actually believe what you're saying, man.
Huh?
I think you actually believe the shit you're saying. That's the scary part. So you can weigh a star by looking at its light and how bright it is. That's what you think.
Yeah, why not?
No, you tell us why. Do you think that?
Because there are very very well studied regularities in how things produce energy.
Okay. Can you give us like some examples of
Well,
how this
we've
applies to
done fusion
stars?
experiments
Just
with
making a general claim about what human beings know about energy doesn't do it for me. You're going to need to tell me how it applies to this scenario with
well,
specificity.
yeah, okay, but all of atomic physics has to do with these atomic reactions that produce very specific energies,
You're going to
right?
outrun gravity. But you would need a priori knowledge of the contents, dude.
A what?
Okay.
A knowledge of the
You make an
contents?
observation, you look at a star, you have an angular size of the star. You don't know how far away it is, you just have the angular size. You don't know how big it is. Then you have your brightness. You can measure, but okay, how bright's the star? It's magnitude frickin', point -1 or something. Okay,
Yeah.
so that's all you know. You got your brightness, you got the angular size. Now, how do you get to? There's this much of this element in there. There's this much of that element in there. This is the fusion process. We know how bright it is, so it must have this much mass. All that shit is theoretical nonsense.
Well, again, each element would have a specific spectral line. So that
Yeah, it's not that. Don't try to oversimplify it. It's not that simple.
Why is it not? Well,
Because
no,
there's effects that there's confounding variables.
like what?
Doppler shift, Doppler line broadening.
Yeah, but again, it's such a specific fingerprint that you can easily
No,
tell
it's
that.
not, dude. It's not. Okay, you just been listening to freaking retards or something. It's not that simple.
Wait, it varies or what? Like the energy levels
Oh,
vary?
dude, there's confounding variables. So you get your data, right? You get your spectrograph, you look at it, but the lines are sometimes they're wider than what you. So there's the ideal of what it should be, but then you get line broadening, right? So it's all smeared out. So you have to
Again,
reconstruct what it was from your data. It's not just like, hey, we just look at it and it's just straightforward.
no,
Then you have absorption. You have intervening freaking gases, right? That'll absorb some of the light. So you don't know the exact rate, like how bright it is in that particular spectrum. Because if you have an absorptive fucking gas in between here and there, it's going to absorb some of the light. So it's not as simple as you're trying to make it. It's actually super complex and theory laden.
yeah, okay. I mean, that's true. Of course, I am simplifying it, but I mean, I don't see what's
Like
so crazy about
ridiculously
the idea.
simplifying it. Like we looked at a rainbow and fucking we know what the stars made out of. Like that's crazy, dude.
Look, okay, I'll put it also like this: like, there are so many people studying this field. You think they're all just bullshitting or what?
They're talking their book.
And they don't have any critical thinking?
No, they're talking their book, dude. Dude, listen. Are you gonna like take it? Like, it's first of all, it's hard to get in astronomy programs because they're small. They're not exactly well funded. Okay, so people get into these programs. You think they're gonna go through the whole ordeal to get into an astronomy, which is basically a fucking useless goddamn job. Go through the whole 8 years to get into some observatory. Then you're gonna start going there and start shitting on everybody, saying what they're doing is bullshit. You're not even gonna get that far unless you're on your knees the whole time, because it's so easy to get dumped out of these programs or not to get your PhD or any other thing. Is tons of roadblocks. I mean, you can just go on YouTube and listen to like testimonials of people like how hard it was to get their PhD in astronomy. It is literally an effort in gatekeeping.
I still feel like there would be a lot of people that would question the data if it wasn't sound.
I mean, how many professional astronomers do you think there are in the world?
I have no idea.
Also, Indio, he's saying
10,000? If it was
he,
10,000, I'd be shocked.
I think they're 10,000. I think so.
but they're all looking at data from observatories and their interpretations. They're saying, "Oh, I see this light in the sky. Therefore, it's trillions of miles away, and these are exoplanets." If you don't go accord to those type of conclusions, you're not gonna make it.
And we have real world examples of this. So we have Halton Arp, right? He was Edwin Hubble's PhD student. He taught at the University of California, Berkeley, and he made something called the Atlas of Unusual Galaxies and Quasars, and he showed that the theory of redshift, that things are farther away based upon how redshifted they are. He falsified that in the 70s. Want to know what they did to him? Oh, you can't use a telescope no more, motherfucker. It's literally what they did to him.
Damn.
Gravity is anti-gravity.
There's a whole New York Times article about it. That when he died, of course, they're like, oh, yeah, we kind of fucked this guy over. But we're going to still keep our freaking redshift nonsense. And we're going to pretend, we're just going to apologize for freaking, taking away, basically sidelining this guy. Now, this guy was a PhD student of Hubble, okay? Hubble is the one that came up with the entire inflationary theory of cosmology. He said if Edwin Hubble saw the data I saw, he would have retracted his theory. Okay? But, you can't go against the paradigm. You guys act like seriously, you act like the scientists are like, they have no human attributes. They're just a bunch of fucking Leonard Nimoy Spocks running around, and it's just blindly applying logic and rationality to all their endeavors. No, they're fucking human beings, and they have the same motivations that any other human beings do. They want money, they want women, they want song, right? They want all the things everybody else wants, and they're gonna do the things, what's necessary to get it, depending on their degree of morality. Some will do more unsavory things than others, but just like any human group of people, and this has been around for thousands of years, you protect your trade craft.
Haven't you seen Revenge of the...
Oh, sorry, Tio. Go ahead.
I said, haven't you seen Revenge of the Nerds, everyone?
Oh, yeah. Nerds.
Hey, guy talking to Indio, do you know of any government agency or any group that in history that are the arbiters of truth, the ones that told you all of the truth and knew everything? Do you know anybody like that?
NASA.
My mom.
She knew the truth.
What about
That's
NASA? Are we forgetting about NASA here?
My mama said something wrong with your medulla oblongata, Colonel Sid.
Is that what you call NASA? Your mom, guy, that's saying NASA?
Yeah. NASA.
NASA is your mom?
No.
She knows the truth?
NASA's my daddy.
Oh. So NASA is the arbiter of truth?
NASA's out getting cigarettes? I didn't know NASA smoked. What's the over-under time on how long it takes this dude to get banned?
Where's that Bacon little brother guy that was talking to you, Indio? Did he leave?
Yeah, you're talking to me now. I own this channel.
No, Parrot doesn't. I mean, let's just cut to the nonsense. The only reason you guys freaking try to pimp gravity is because you think gravity forms balls. So let's just I'll grant you all that shit, all the fucking gravity nonsense. What's the evidence? Ultimately, if you're going to say gravity forms things into balls, you're going to need to actually back that up with an observation or with an experiment, which you don't have. Even if it was your physics prediction of a model, say you had a model, physics model, and that was your prediction, you'd actually have to go out and do the observation or the experiment that shows gravity forms things into balls. Nobody has ever, ever, ever observed that happening. Saying, well, it takes too long, or we see balls now, but that's how they were formed, we just know it. That's not evidence that it actually happened. I could say, no, those balls were formed from, three-toed fucking magic gnomes.
Is
Right.
Indio growing up? You believe in gravity now?
Oh, dude.
Cute.
If you didn't eat breakfast this morning, would you be hungry? Or how would you
Believe in
feel?
gravity?
If you didn't eat breakfast this morning, how would you feel, dude?
Yeah, I'd be pretty hungry.
Okay, cool. You can do hypotheticals. So what I said was a hypothetical. It's called an internal critique, dude. You
So you
guys
don't
are
believe in
fucking
gravity?
heads. Is it a belief? Is gravity a belief, dude?
I muted Fiddlebone. We've got let's ask the scrub. He's really wanting to tell you about gravity.
Oh, hey guys, I think I've been unmuted. So I'm sorry I wasn't listening. I had my sound off. But you want to talk about gravity?
I mean, I guess.
Well, someone was disputing if you sit in a chair that whether you have gravity or whether gravity is real. Perhaps I don't want to put words in his mouth.
Well, what do you mean by gravity, dude? This is always the rub. The conflation.
No, I mean,
is gravity the cause of the effect?
It's a very strange
of
thing
sitting in a
because
chair?
everyday objects are way too small to have observable gravity, but big objects have gravity.
Okay, you got any evidence for that?
Yeah, I mean, if I'm sitting in my chair right now,
Uh-huh.
and if I were to clench my abs and I have no gravity, I would start floating.
Okay, that would be the effect, or is that the cause? Like, what are you talking about?
Well, I'm just saying,
And
if I
you're
was
claiming, why would you
in
start
a
floating?
zone
Where'd
that
you
had
get
no
that
gravity,
idea?
any motion away from the surface.
So you're making all these predictions and claims, but I don't see any evidence. You said there's no gravity among small objects. I asked for the evidence, and you said sitting in a chair.
Okay, so if I were to hover my hand over an apple, it will not pull into my palm, will it?
Dude, if you knew that happened, right? If you know that if there was no gravity and you clenched your abs sitting in your chair, you'd start floating away from your chair, right? You know that, right? How do you know that?
Well, I mean, people have done gravity or floating experiments with planes that are descending. I mean, it's not a.
No, they're not floating, dude. They're falling. They're not floating. They're not floating. They're falling.
Yeah, but if
they're
you
inside of a plane, the plane is falling. They're falling. If the plane was transparent, you would see that they're both falling at the same rate.
If you accelerate towards the Earth at a fast enough speed,
little
you will
G,
feel weightless.
Because you're falling.
Yes. You neutralize the effect of gravity. Gravity is a form of acceleration.
Oh, Jesus Christ. Okay.
I'm making this as easy as I can. It's simple.
No, you don't know what you're talking about. Okay. When you fall out of an air, when you're falling inside of an
experienced gravity in your life?
Okay, you're conflating two different ideas. So there's little g and big G, right? One is the acceleration of gravity on Earth, little g, and the other is big G, mass attracts mass. How do you get from one to the other?
Well, the Earth is massively bigger than you and I.
So, okay, that's cool. How do you get from one theory to the other one? How do you connect the observation?
Well, I suppose if you were to go on the surface of the moon, which is smaller,
Oh God, dude.
you'll
No, we're
observe
talking
a
about the
lower
Earth,
amount of
dude. Don't
gravity.
try to go into your space fantasy, dude. No one cares about that. Okay.
Well, I mean,
how do you
other than
get
that,
mass
the other thing
attracts
you can
mass?
see,
How do you get to mass attracts mass to why things fall? Logically, connect it for us.
logically. So
Yeah,
if I hold
logically,
something out at
connect it.
arm's
Make the
length and let
connection.
it go, what happens to it?
Yeah, false. Now,
Yeah.
demonstrate the cause of that as mass attracting mass. Go. Give us the experiment.
Give us an experiment.
Yeah, an experiment.
Well,
That
I
the
just gave
cause
you
of
an
a falling
experiment, so I don't
object
know.
you dropping.
When I tell you an experiment and then you say no, give me an experiment. Now I'm lost. I don't know.
No, hold on. Your experiment, that was the effect, right? That was the
Yes.
observed phenomenon. Let go,
Yes.
apple falls. That's the
Gravity
observed
is an
phenomenon.
observable event.
Now we want, now we want to know what caused that to happen.
We're standing on a planet.
Okay.
Yeah.
That's not a cause.
Yeah, it is.
What natural phenomenon caused that to happen?
Okay.
You think it's mass
I believe I'm
attracting
saying
mass?
this, but an agglomeration of rock came together.
Yeah, dude, I don't want a
and
story.
created a large amount of mass in one place.
I don't want a story. I don't want a story. I want an experiment.
I don't know what else to tell you.
I want an experiment.
Do you want to cut the Earth in half and see if there's less
No.
mass?
So the scientific method, if you want to know the cause of a natural phenomenon, you do an experiment, right? So you have an independent variable, which according to you is mass attracting mass, and then your dependent variable, which is your effect, the falling apple. Okay? So we have a falling apple. That's our effect. We want to know what causes that. You think it's mass attracting mass. Okay, give us the experiment that shows mass attracting mass causes an apple to fall. Yeah, nobody can do that. Nobody can do that experiment, dude. Laugh. Dude, your nervous laugh. It's hilarious. Dude,
well, I'm
dude,
not
you're
even
nervous.
nervous. I mean, I suppose when you're trying to go beyond that, I mean, you're going to need some really high end machinery. I think. I mean, it's.
No, we can do that experiment.
This is like asking whether the sun is bright. I mean, it's like how.
No, we can do that experiment.
I mean, I guess.
No, we can.
I guess
No, we can do that experiment, bro. We can do that experiment because we can take a bowling ball, right? And we could take a frickin' a bus, and we can both throw them both off a cliff. So we manipulated our independent variable, mass.
Okay.
Do they fall at a different rate?
I guess they would, depending upon wind resistance.
Oh, gee. No, we're not talking about wind resistance. We're going to do it in a vacuum chamber.
Okay.
Okay. Do they fall at a different rate?
Well, in a vacuum chamber, they've proven that a bowling ball and a feather fall at the same speed.
No, okay, cool. That's actually not true, but whatever.
No,
Let's say it is true.
You want a video?
No, it isn't. No, it isn't. Yeah, you didn't watch it close enough.
I'm telling you, in a vacuum.
No, you didn't watch the video. You didn't watch the video close. You didn't watch the video close enough. Watch close.
This has been repeated hundreds of times.
Hundreds of times in the NASA vacuum chamber.
Hundreds of times.
You're making shit up, dude.
I'm not making this up. I don't care. I mean, I'm not in the bowling ball feather measuring business. I don't make any money off of doing this experiment. I am not financially tied to this.
Yeah,
I have no.
Yeah, but you're making. Then why are you lying, dude? There hasn't been done hundreds of times.
Why do you think I'm lying to you?
Because it hasn't been done hundreds of times.
I'm lying to you.
Because there isn't vacuum chambers running around everywhere, dude.
People make vacuum chambers in
that are fucking that are multiple stories tall.
People make vacuum chambers
that are multiple stories tall. Yeah, that they're not multiple stories tall, but you can drop a bowling ball and a feather in them. Are they?
It's been repeated over and over again. They love to show this to the physics students.
Are you saying that because you saw the video over and over again, they're doing that particular observation over and over again?
I'm telling you that without even a shred of doubt. Not even, I mean, we're talking like as fundamental as the nose on the end of your face. Is there any doubt whether a feather and a bowling ball fall in a vacuum at the same speed?
Yes, you didn't watch the video close enough.
You might as well argue that the sun doesn't produce light.
Okay, that's not an argument. That's not an argument. Look, you didn't watch the video close enough. They do not fall at the same rate. Watch it closer. Okay,
Wow.
so if you watch the release mechanism, when they release the bowling ball and the feather, one starts falling before the other one does. That means they don't fall at the same rate. There's a release mechanism. It's a freaking metal bar with a slide, and it slides to the right. And when it does, it releases both the objects simultaneously. But one doesn't start falling when the other one starts falling. You can see it move where the other one hasn't moved yet. Now, this is in NASA's freaking vacuum chamber, which is supposed to get down to -6 torque. Okay? So you didn't watch the video close enough, and you're sitting here trying to tell us it's ridiculous claiming the opposite.
Were you
didn't,
predetermined that you wouldn't accept the outcome? Is that where you're coming at? Like you've already decided.
You're just showing your own. Don't try to project your own bias onto me.
No, I'm not. It's not my bias.
No, you're projecting your.
If you have a bias, is it
post
possible?
The video in chat.
When you started watching that, you desperately wanted it to be wrong.
It's a rejection with justification, asshat.
You're allowed to have your opinion, and if your opinion is
it's not an opinion,
no matter what, then fine.
It's not an opinion, dude. Can't convince you. It objectively happened in the video. You cited.
Well, I mean, I can dig it up if you want. Do you want us to watch it together?
I'm going to post it in the chat right now. I'm going to post it in the chat right now.
Fantastic. So,
okay.
So
now watch it closer.
If you're in regular atmosphere and the distance is significantly different and easily observable under regular atmosphere, that the bowling ball's much faster to drop, and then you put both of them in a vacuum chamber, side by side, and you drop them, and they fall at the same speed, observably.
No, they don't. No, you just saying something.
Like, oh my goodness, that can't be right.
Observation isn't what you said.
It has to be wrong.
The observation isn't what you said. I just posted.
This can be backed up with the Bremen drop tower, you know.
Yeah, then there's that. There's the fourth story.
I find it astounding.
You're just chanting like a nut.
Fundamental things
like a nut,
that are literally as obvious as the nose on your face.
No, they're not. You're just chanting, dude, like a nut.
I'm not a nut.
We're giving you what the empirical evidence actually shows, and you're just rejecting it for your idea of what it should show. So you think it should show X, and everybody says it showed X, but you didn't watch it close enough, and so you have a confirmation bias. So you looked at it, and you weren't paying attention. You just looked at the end. Oh, it looks like at full speed, looks like they hit at the same time. Well, they did it in slow motion too. And if you look really closely at the release mechanism during the slow motion, they don't fall at the same rate. The feather, the entirety of the feather doesn't even fall at the same rate. So the theory of gravity is every particle.
I'm looking at your video. Yeah. And I'm absolutely dead serious. I'm seeing the feather and the ball move in tandem as though they're standing, as though I put them on like a placemat and drag them around, on the floor together. I am literally looking, and they're moving down.
We're talking about when they're released.
So if there's a minuscule differential in the release mechanism, you want to harp on that all day?
No, it's fine. We're still talking about the effect. I'd like to have the cause. Can you give me the cause? What the gravity as a cause? Can you do that?
Hold on. Is there a differential in the release mechanism?
Gravity. I don't know how gravity as a universal reality became into existence. Couldn't tell you.
Okay, so you only have an effect. You're describing an effect. You don't have a cause, but you're calling it gravity. So why don't you just say the observation I make is of things falling. I'm calling an effect gravity.
Do you have it? Does the word gravity offend you?
No. Why would you say that? I'm just letting you know you're not using the term correctly.
Do you guys all want to call it something else?
No, I'm fine with little g. Little gravity's fine.
Yeah, no problem.
The mass attracting mass is bullshit, and you still didn't give us the experiment. And not on the video is not a refutation.
I don't know what. Honestly, I have to be truthful, sir. I don't know what would change your mind. Maybe nothing.
An experiment. I'm telling you right now, an experiment.
Well, you just gave me a video of a feather and a ball that were moving imperceptibly the same speed, and telling me that they were different. So we can't even agree.
It literally shows one falling from the other.
Then I don't know that I can prove anything.
Okay, dude. That video shows one moving before the other.
Well, maybe at a like a millisecond difference. I mean,
Is there a time delay? Does gravity have a time delay?
Well, if you have a tiny difference, it's kind of like when two guys decide to drag race each other. One of them technically is going to get off the line faster than the other one.
Okay,
Not by much.
but listen. Okay, fine, dude. That's fine. But you know what? That works against you because the one that is released first falls last.
The one that releases. Well, when I saw your video, they're falling at the same speed.
Dude. Okay. The bowling ball was still engaged while the feather side was not. But the bowling ball starts moving before the feather.
I'm not seeing what you're seeing. I've got to be honest with you.
Yeah, because you didn't really watch the video.
I did watch the video.
No, you didn't.
I just watched the video. You don't trust anyone, dude.
This isn't about trust. You're a liar. You're a liar. You didn't watch it, dude. You're sitting here saying, when I did it frame by frame, it shows...
I'm going to watch it one more time just to make sure that I haven't missed it.
Actually, pay attention to it this time.
Frame by frame.
Yeah. Okay, this is from Brian Cox's vacuum test, okay? There's a green light and looks like a twist switch. There's arrows. The delay is slight but perceptible. And then they're released and they're going down.
At that point, you need to go back and rewind it. Okay?
They are moving at the same speed.
Go back and rewind it.
You guys pointing out the part where the feather begins to fall first?
Yeah, funny you should bring that up. This guy says he can't freaking see it for some reason.
Are you kidding me?
How close did you watch? Question mark. Listen, if you did, you noticed the feather being released 0.1 seconds before the bowling ball.
That's
have I watched the video? Left still engaged, right is not.
Yeah. The feather definitely begins to fall first.
Do we have agreement that I'm watching the video?
Yeah, and we have agreement that you saw a differential.
Okay, so 0.1 second release difference in your mind invalidates gravity.
Yeah.
No. It invalidates a particular claim about gravity.
Well,
that's true.
Okay.
That's true.
Okay.
So you have a problem with distinguishing things, okay, in nuance, okay.
Wow.
But you're whistling like this is just deflection. Give us the experiment.
I said I would watch your video, and I watched it, and then you didn't believe it. I watched it again, and I announced the whole thing.
Yeah, you're fucking blind then, because anybody can watch it and see it. I don't care if you want to be in denial, right? I can show you other experiments. The Bremen drop tower, which is a four-story vacuum chamber in Germany, where they drop a bunch of different elements in a capsule that also show they don't fall at the same rate. That's not the important part. The important part is there's no correlation between mass and the rate at which something falls. Okay? So if mass is the causal mechanism for a falling object, when you manipulate the independent variable, you should see a change in the effect. The effect being the acceleration of g. Nobody observes that, and because that's not observed, then the cause can't be mass attracting mass.
Okay.
You understand what I just said? So, a scientific experiment, to determine the cause of an effect, you manipulate the independent variable to watch a change in the dependent variable, the effect. Your claimed independent variable.
Your argument here is that if something is more massive.
Listen to what's being said to you. Did I say anything that was just wrong just now?
Going back to your first statement. Are you?
The cause of an effect, dude. No, the cause of it. No, don't say what I'm saying is. Okay, listen. The cause of an effect. We're going to keep this super simple for you. The cause of an effect. How do you determine that experimentally? The natural phenomenon. Something falls. We want to know the cause. How do we determine that experimentally?
Man, shut your bitch ass up. What the fuck, bro?
Yeah, that's a great reputation.
I mean, isn't the thing that we're trying to measure here how
Why are you
far
not answering my
how fast
question?
something will fall? I mean, isn't that
No.
what we're looking at with
No.
gravity?
No.
It's not what we're looking
Trying
at.
to determine why, if it does fall at different rates, it's irrelevant. We want to know what the cause of that falling is, regardless of what the rate is. What changes the rate at which it falls? If it doesn't change it, what's the cause? Why does it fall?
If it doesn't change, okay. Well, one of the things
what everybody does
that people go over with gravity is that the further away you are, the less of the effect of gravity. So if you measure gravity, at sea level. You measure gravity again at 1,000 feet, at 10,000 feet, at 50,000 feet, 100,000 feet. You'll see that things will accelerate slower as you get further away. In fact, I'm willing to bet that there's a distance you can go to where you can't observe any acceleration towards the Earth anymore.
Is this a logical argument?
No, I'm just saying, if you wanted to see a variable, I'm giving you an example of something you could do to change the variable.
Yeah, because you think it's the inverse square law of mass.
So elevation causes things to fall. That's your independent variable, elevation. That's your cause.
I'm saying that if you could drop something from, let's say, 100 miles from Earth,
that's just a correlation. That doesn't mean anything.
Show that there's less
That's
gravity.
just a correlation. It doesn't mean anything, dude. It's a correlation. It's a correlation.
Well, I'm trying to answer your question as best I can. All I can do is the best effort I can. I may not know how your brain works and how I can possibly.
It's not about my brain, dude. It's about your fucking sped education. It's a correlation. Correlation isn't causation. It's like the first thing they teach you in university.
I see. All right.
Okay.
Right. You're trying to back up observations with other observations as if they're presumed causes.
Right.
Yep.
So this is the problem with gravity. It's circular. You guys have to say the cause is the effect. This is why Newton didn't believe it. Newton knew it was trash. Yeah, Newton didn't believe in gravity, dude.
Newton didn't believe in gravity.
He wrote a letter saying anyone that did believe it was basically retarded.
Okay, fine.
he actually said that.
Yeah, he actually said that.
I guess I'm just going to have to assume that there's no gravity.
No,
good for you.
You have to assume that things fall, and if you want to call that gravity, that's fine. That's completely descriptive. There's nothing. But when you start saying, "I know what causes that," that is another thing. That's something different.
I see. So we should just
and then you extrapolate out
that massive objects have gravity.
Yeah, that's what you're trying to demonstrate, dude.
No, I'm asking you. I'm saying, so what you're proposing here is that we just wholesale reject that massive objects create gravity.
Well, until there's evidence, sure. Why would you accept it without evidence?
I don't know. Maybe none of us have the ability to reproduce all scientific experiments. Do you understand?
Well, what did they do? What did the other people do?
I mean, I understand that there are people who are into research science, and I think someone taught making or echoing or something there, but I'm sure that there's somebody who has fun.
I'm sure magic science guy fallacy. I know there's a magic science guy out there somewhere that proved with an experiment the things that I believe. I know he's out there. I just need to be able to, I just can't find it on Google. Maybe if I just look longer.
Hey, people do experiments on French fries.
Yeah, he might be a witch doctor too.
People do experiments on candy.
Okay, give us the experiment on.
They're not scientific. Like, listen, like people experiment in the bedroom too. Those aren't scientific experiments. We're talking about scientific experiments.
Okay, all right. So can we get back to the one as well? Now that we've talked about gravity, I think we've killed gravity now. So do we want to talk about air
gravity?
No, because I want to get to the point. What the point of it all is? The point of it all is that you guys go drop pencil, therefore Earth ball. Right? But there's a whole string of logic that needs to be inserted in there to reach that conclusion, therefore Earth ball from drop pencil. You don't have the middle part. The middle part is thing fall, therefore mass attract mass, therefore Earth ball. And even if all that was true, you would still need the observation. You would still need the observation. Gravity form Earth ball. Gravity form planet ball. Gravity form ball at all. Do you have any observation of that ever happening? Do you have an experiment? Let me get this. I want to settle something now.
I do. I hear what you're saying, brother.
Is science empirical?
And quite frankly, the electromagnetic or atomic causation of gravity is just not a concern for me.
There is no atomic theory of gravity. If you look at the standard particle physics, gravity is not included as
each other, and I've just never measured it. I've never worked on the research.
There's got to be something.
I mean, I'm really not worried about gravity stopping anytime in my lifetime.
The point is that even if you had a coherent theory of gravity, you would still need to demonstrate it from experiment or observation, because science is empirical.
And you still don't have a proof of a globe Earth.
So are you and I scientists? Is that what we're making the argument of? Is that we
are scientists.
The science of gravity?
Yeah, we are scientists. Yes, we are.
Okay. Well, I don't get paid to do science. I get paid to do finance.
Do you determine science and I do finance too?
Yeah. Did you determine cause and effect relationships?
Well, I mean, I know that
it's a yes or no question.
And sales generate money. But if you were to tell me why do sales make money and why does it do expenses spend money, and you can't understand what revenue and expense are, then I'm stuck.
Okay.
Holy shit.
What causes revenue?
You do a transaction that someone pays you for doing a product or service.
Yes, someone pays you. That causes revenue.
And so if you want
so you just did a cause and effect experiment right in front of us.
If you then want to argue, well, what is money and what is a sale and why is a sale and how do sales ever happen and how do we know that it's a sale and I mean, when you go deeper than that, then you're just going off the track to the point where I don't have an answer for you.
It's just obfuscation, dude.
No, I'm telling you, if you want to go deeper than that and well, what do you mean it's a sale?
Look, the only thing I want to go deep in. Well, I'm not going to make any jokes about the planet.
Your mom.
Anyway, look, the claim that Earth is a ball because gravity forms balls.
I don't care if in your mind
why are
Earth
people
is a
even
massive
making that
flat
argument,
object. I don't care if you
said it's a flat object.
I don't care. I seriously. I don't care if you believe that the Earth is 2 inches deep and 50 quadrillion miles across.
You're just
inches deep in your mouth.
He's fucking spiraling, man. They always spiral into some fucking troll.
The Earth is 2 inches deep. Nobody's ever fucking claimed that. What the hell?
Yeah, it's a fucking record. With a little hole in the middle, and we're on a big record fire.
The deepest hole ever dug was like what? 5 miles, 7 miles in there.
No, it was your mother. That's the deepest hole right there, dude.
Yeah. Okay, bud, calm down. Well, that was a good one, Indio. Well done.
Thanks.
Yeah, thanks.
You should have heard me. Actually, last night was crazy, dude. It was pretty good. It was funny. That big tech dude was in there. You guys remember him? It was kind of funny.
Big tech dude?
Yeah, dude. He was like pulling like multiple Xanax, right? Where he kept trying to he'd say something and then we prove him wrong and then he'd try to take our position. Pretty funny, dude. He kept doing that over and over again. Just hilarious.
I might have to rewind. I thought I got caught up on everything, and I think I probably fast forwarded through all that. So let me go back later and go check that out. We got some crazy.
We were talking to him for a while. Yeah, we were talking to him for a while, so it's possible you missed it. He was kind of all over the place.
Yeah, what was his name?
Big Tech. He's been in here. He's also been over in Earth Awakenings and shit. He's been in our server. So.
Okay. Cool beans. Yeah, and thanks for adding some extra clarity to the molecular kinetic theory of gases I was going into earlier. So, always appreciated.
That's the thing, dude. It's like serendipity, right? That's what we were talking about last night. And I brought up Avogadro's law. I haven't brought it up in like, I don't even know. I haven't talked about it in like 2 years. So and then I heard you say it, and I'm like, oh shit, dude, we just talked about that last night, man. I'm like, freaking just total serendipity here.
Oh, really? So I've been talking about that the last few months because it's been my thing now. And I've got a really well-polished presentation on it, if I say so myself. And then I heard you pick up on it the other night, if that was last night. And I was like, oh my God, Indio's listening to me. But I think you probably came up with that on your own, so. That's how it goes.
The thing is, like, dude, I never catch you, man. I mean, I do sometimes, like, I'll hear you in the chat, but it's always like, fuck, dude, I'm always doing something. Whenever I listen on the live stream, it ends up being freaking play or something, I'm like, fuck, I don't want to listen to him. Or fucking Democ. I mean, I like listening to Democ because he's fucking funny. But, like,
he's funny.
There's only so much, you have to take him in small doses.
Mm-hmm. Yeah, so Avogadro's law is my number one go-to now for the debunk of the gas gravity thing. And it's been wonderful because there's so much you can build off of that. Like the ratio of gases I was talking about earlier maintains the same thing as you go from sea level to a mountain. So no evidence there of gravity pulling the bigger masses, heavier masses down first. There's so much. The frequency distribution is not mass dependent at all. So it shows that pressure is frequency, the speed and velocity of the molecules relative to the volume and not the mass. So there's just so much you can build into it. And it's been a really exciting development, I think. And I'm hoping others pick up on it because Avogadro's law for the win, folks.
I used to use it in a completely different context. I would use it as, because Kovros would say that mass is the quantity of matter. And I would use that as an example where it can't possibly be the quantity of matter. Because
it's the same.
Yeah, because you have the same number of molecules, but if you count all the other electrons and protons, right, then it's not the same amount of matter. It's actually different, but it would be the same. Like, so.
Right.
I see it in a different
contradiction.
Yeah, exactly. Like you have a big hole there.
Yep. That's a good one too. Yeah, I mean, and also describing the entropy of gas, like by the mean free path of gas molecules, when you have a vacuum, you expand more potential, more possibilities for the free paths to go, which increases the number of microstates of gas molecules to be in. And gravity somehow reversing that and compressing gas molecules and making heat. I think that's another funny exposition of the problems in physics.
Yeah, where's our gravitational fucking heat engine?
Yeah,
right?
It's compressing shit.
Yeah, it's got to be compressing it and heating it up, right? Like it should just be getting hotter just from the gravity.
So let's just make a big fucking diesel engine based off of gravity.
There you go. I mean, we could just rig some contraption and make a perpetual motion machine.
Yeah, so like diesel engines don't require spark plugs to send the piston going back in the opposite direction. It's based off of compression, only compression. So if gravity is the key driver of compression of gases to pressurize Earth, then you should be able to build a fucking diesel engine big enough that uses the potential of gravity in order to move pistons and compress gas and create a perpetual motion machine for internal combustion.
Yeah, I mean, gravity, it's freaking everything, dude. It's a perpetual motion machine. It freaking does everything, right? It never runs out of energy, right? Like, gravity isn't going to like, oh, gravity ran out and we're all going to float off the ball, right? Like, they never say that.
Nope.
Like, the energy never gets used up. It's just infinite energy forever and ever.
Yeah, earlier when you were talking about free fall, I wanted to interject so bad and say, so how would you tell the difference between somebody who's being broadcasted from the ISS and somebody in a vomit comet? Right? Because the ISS operates on the same free fall principle as a, you know, C-141 or whatever the fuck, doing these big parabolic arcs over Earth. You could not tell the difference. And in both cases, they're both claimed to be falling, which is kind of funny. Because now you can't, NASA has to say, yeah, they're falling. They're absolutely 100% falling, but they're falling around the globe.
Yeah, they're just missing it. They're just missing hitting it. So they're just falling around the globe.
Glancing blows. Yeah, and so I'm like, okay, fine. Where's the rotational vector? Because you got to maintain a down relative to the center of mass. So where's the rotation? You got this angular displacement and a rotation happening at once. Show me that rotation, dude. Show me the rotation of satellites in low Earth orbit. I want to see them doing fucking 360-degree somersaults every 90 goddamn minutes. They can't do it.
Look, I actually did this once. So you can take the curve calculator and calculate how far it has to drop to maintain its altitude. And then, okay, in 1 minute at 17,000 miles per hour, I've traveled this far. How far do I have to change my tangential vector to go down, right?
Oh.
And then, okay, then you do the calculation for, in that same amount of time, 9.8 meters per second squared, how much will I have fallen? They don't match up. You won't fall enough. You should be shooting out into frickin' space.
Yeah.
Because the drop
I
at
was thinking about that
17,000 miles
earlier,
per hour is
a couple
few
years
miles,
ago.
dude. Yeah, it's a few miles.
Yeah, they don't match up. It's fucking weird, man. So the gravity, the rate of fall and as claimed by gravity can't match Earth's radius. So Kepler fucking got cooked.
I mean, that's why they use
Kepler,
that. It's the orbital dynamics is like a kinematic model that just uses time variables, right? And it's really just geometry. It's not dynamic at all. So they don't deal with any forces like 9.8 meters per second squared. They don't deal with any of that crap.
No, they don't. They actually upload Keplerian orbital elements to the GPS network from Shriver Air Force Base. So what they do, they take all the ground monitoring stations from the GPS network worldwide, which is based off of alt-az or LAS, elevation and azimuthal angles relative to where they are in WGS 84. And then they send that to Shriver, whatever fucking Air Force Base, and they do the computation, and they say this is where the GPS satellites should be. And in subframes 1 and fucking 2, whatever, they then take that data, crunch it, and they send it up into the satellites. They tell the satellites where they think they are. The satellites don't figure out where they are themselves. They get told where they fucking think they are relative to a model of a globe.
Here you go.
And then they apply all the corrections, longitudinal corrections, timing corrections, ionosphere, fucking electron density connections. And this soul who's in chat right now, God damn it, you're gonna get fucking banned.
I'm gonna take care of them permanently. Well, at least it's.
Yeah. So GPS is garbage in, garbage out. They take flat Earth measurements. They apply them to a spherical coordinate reference grid. They compute Keplerian orbital elements. Meanwhile, that and the previous step were both philosophical preferences, mathematical, inductions. And then they tell the satellites, this is where we think you are if Earth is a globe. And then the satellite retransmits. I mean, they're doing the raw timing data, right? So in Rhinex, and then the raw timing data then gets computed back into a globe again for ECEF, which is based off of, it uses spherical geometry based off of a coordinate reference plane. And then they deliver that to devices, and devices then use a local reference Cartesian grid in order to tell the user where they think they are, and then they compute that back into fucking WGS84 Latin long to make the user think they live on a globe. It's insane. It's so complex. It's hard to like go through all this really fast with some dipshit that wanders in and says, "Hey, satellites prove that Earth is a globe," and I'm like, "Oh goddamn!" They're like maybe 3 or 4 instances in the whole process where they're doing coordinate transformations. How do I explain this to a guy who's got at best like 8th grade math skills?
Yeah, dude. Like, listen, like I keep running into this over and over again because I try to tell them, hey, latitude and longitude on the Earth, it's in the sky, and I go, I'll prove it. If I black out the sky, how do you find your latitude and longitude? And they go, GPS. And I'm like, oh, fuck, dude. I'm not going down this freaking rabbit hole, man. Like, no way.
I don't know if I could possibly explain it more expressly than I did a few minutes ago, but that I hope captures the gist without compromising on integrity of everything. I mean, it is extremely complex, but I think I fucking figured it out.
Well, I mean, dude, and this is why. So I'm not sure if you're keeping up on the Ukraine-Russian war. All the GPS munitions from the United States are fucking useless.
Yeah, they're
okay. So it's the same rule. The more moving parts you have, the more likely whatever machinery you concocted is going to fail. And they have a lot of moving parts, man. Like, it's a Rube Goldberg device. That's literally what it is. It's a fucking Rube Goldberg device. And it's really easy to break it.
Yeah, and so people like on the user side think it's a black box, right? They're getting all the Rhinex data and shit. And they have no idea that part of this includes telling the satellites where they think they should be using Keplerian orbital elements in reference to WGS84. That the satellites take that information and bake it in. So it's really not an open source system. There's an entire freaking dinosaur tail to the tooth ratio that the user sees. There's a dinosaur tail of proprietary black box involvement that goes into this. And when you read all the open source literature, they begin with fucking flat Earth.
So here's something I don't understand about it, right? So they say there's atomic clocks on the satellites, or are they getting their? They're getting their clock from the ground.
They're getting their gosh, there's no freaking maser and optical maser and resonating cavity on the satellite. They're getting it from the ground, I think, from the Naval Observatory or something. I mean, I don't think they have. I don't know. I don't know for sure.
Okay, so
I can't see
the
that they have one.
So you have a receiver. How do you know the time of flight unless you're synced with the clock?
Yeah.
Right. You need the reference clock. Like, okay, it left. Here's the satellite time. It left at this time, and then you got it, and then you got your time. How do you know what your time is relative to their time?
Yeah, you have to be told, and that goes into the whole epoch.
Yeah, man. Like I don't. I've always so I know the network time protocol because I always thought about hacking it and changing everybody's frickin'. So when Wednesday rolls around, it's Wednesday again, and fuck with everybody. So,
well,
because it wasn't secure. It wasn't secure, man. Network time protocol wasn't secure, but when you turn on your computer, it gets its time from the network time protocol. Just frickin' hack that shit, dude, and send out fucking. It's still Wednesday, dude. Everybody goes fucking Wednesday again.
Yeah, I mean that's how a lot of hacks are done. Dude, that is that's a classic hack, right? I mean, and if you were to get into hacking SCADA systems, hey, we're gonna.
The point is, they got their
the centrifuges 5 seconds later and fuck up the experiment. You know?
All right, fuck yeah. But they have the atomic clock in Colorado, which is what the network time protocol. That's it's the base clock. Or at least it was. I don't know how it works now, but this is how it used to work. Almost anybody that was using network time protocol would get it from the atomic clock in Colorado.
Yeah.
Now, theoretically, everybody's phone and GPS could be using that, and that could be synced, right? The satellite could be synced to that. But like this is like the best case scenario that I could think of in favor of fixing the time problem of the receiver. But like I don't know. I haven't like looked into it how they know their time relative to the freaking satellite time. So how do you know what the time delay was?
Right, like if general relativity is true, how do they figure out which reference frame they need to adjust or alter because they're all
Well,
supposedly equal?
Well, I thought like you're getting the distance to the satellite by measuring the time it takes for the signal to go from the satellite to you, and that timing signal was independent of any coordinate, right? So you don't even need to know where the satellite is. You're gonna deduce it from a bunch of other satellites, right? Timing. You don't need to know where they are because you're just timing it, right? Speed of light.
Well,
You know
hold
where you're
on,
gonna
but some
be.
of the satellites aren't in view of the others supposedly because Earth is a globe, or the satellites are at such a narrow angle of incidence that the signal can't be received.
I know Shane's probably putting all the answers in the chat, dude. He's just fucking spamming that shit. Well, I thought it was independent. I thought the time thing was independent of the coordinates.
They're
Like,
not following
they didn't even. But
geodesic arcs,
obviously, they're not. If they're putting the satellite's coordinate into the system, then it's not a system independent of their fucking manipulation. Like it's
Right. So that's one of my contention points here is they have to be curving the signal of the satellite in a geodesic. They have to be applying corrections like this to make it work on a globe. And we know they do that already. Like longitudinal corrections, timing corrections. I mean, they bake it into ionospheric corrections. There's so many different places where they can apply corrections. It's like with a geodesy and surveying. They got their curving plumb lines, their astronomical refraction. They can apply corrections any way they want, and that's where it hides. That's where the globe mathematically hides within the error tolerances that are so wide you could drive a bus through them, and the bus drivers like the globe.
yeah, and nobody's gonna know the difference. Like, I mean, I know you've heard me say this, Rick. Always like when I drive from frickin' New York to San Francisco, like the distance always comes out correct, dude. And if it didn't, what are you gonna do about it? Like, it's frickin' I got there frickin' 3 hours too early. What are you gonna do? You're gonna call the National Geographic Survey, dude, and be like, "This isn't as far as you said it is." Call the president. Call like nobody's ever gonna notice. You would never notice. For practical purposes, nobody notices like the discrepancies.
Yeah,
just like
the
when
end
nobody
user can't
noticed
be
that
accurate enough.
Yeah, it's like the Chicago skyline, like how all this shit started. Nobody noticed the discrepancies because nobody knew there was a discrepancy. They were like, "Oh, let's check the math." Oh shit, that don't work.
See, yeah, it's like two problems. The end user is incapable of having the accuracy to such a degree to determine anything. And then on the back end of GPS, at least, you've got the black box of corrections that are applied before the signals are sent out.
Yeah, and Glover's just like, "How do I know where I am? Use GPS every day. You get GPS in." First of all, GPS didn't even work. So where I live, they just like it used to be like they're redeveloping it. It used to be like an old railroad yard, but they're building like high rises and fucking biotech fucking companies and bullshit. But when they first started building up over here, because no one ever came over here, like no one ever like in this section of town, GPS wouldn't work. Like people would walk around and they'd have to ask me directions because they'd be staring at their phone. It just wouldn't work, dude. Because
I'm old enough to remember that in spotty places in like Northern Virginia near the nation's capital. Like what the hell?
Yeah, but the thing is, they've been constantly collecting data all this time, right? Everybody's little Android phone, as they're driving around, right? It's giving them freaking location services data. Everybody's got their shit turned on. They're mapping So did you hear about the Pokemon shit?
Yeah, I did, and I can go a step
The
further back
Pokemon
from
Go?
that. So have you heard about Skyhook that preceded the Pokemon shit? So
No, I
Project
didn't.
Skyhook, yeah, Skyhook was a company that was contracted by the Air Force to basically do war driving with airplanes and pick up every
Oh
EM
shit!
Yeah, and
Wow.
so they picked up they geotagged every like static EM emitter, radio stations, people's Wi-Fi boxes from their houses, and I mean like everything. They
Is that
took a bunch of
classified?
planes
Can we get
around.
a? I
No,
want a
no,
good
no.
picture.
The company was called Skyhook, and they brag about it. That's what went into DGPS.
Oh, dude, I'd like to get that map, dude. That would be cool.
Yeah, yeah. I
Might
mean,
be
it's like
outdated
most of
now,
us
but
have to know. Skyhook.
yeah, and there's like other things, right? So like airports, they use like a VHF system for positioning and shit. They don't actually. They use multiple positioning systems, right? So
Yeah.
GPS, differential. They use something called WAS, which is like
Yeah, I've heard
wide
of that.
area. Yeah, so they use a whole like, and I mean, I would do it too, right? So these systems are for like some don't function under certain weather conditions. VHF would just work in any weather conditions pretty much, unless there's lightning, right? But the other ones, they're like because they're higher bandwidth, and so
Yeah.
in you have levels of precision, right? Like the VHF is the lowest level of precision, but it frickin' works in the worst conditions. So they have these redundant factors. But a lot of people don't know
Indio,
about this stuff.
refraction is a problem, Indio. It's refraction.
Oh yeah, that must be it. It's refraction.
That's what's causing the path to take longer. Yep.
But we have all these systems, and they're like GPS, Google Earth. Like it's so remedial, dude. It's like it reminds me of the saying, "Ignorance is bliss, 'tis folly to be wise." It's like these people are just like they took that shit to heart. They're like, "I'm happy. I have a GPS. I have no idea how it works, but I can get to Pizza Planet." Like,
That's funny, man. I gotta go in a second. I gotta do something, but I'll be listening.
yeah, me too. I'm gonna take a break for a minute. Shout out Shane St. Pierre.
Yeah, Shane. Shane. You're a brother, bro.
I know you know this is his subject, man. GPS, dude. Him and Alan love that shit. I mean, I like it too, but like, problem is talking about with somebody, right? So I don't want to learn. Like, I mean, I know more than the average bear about it, but not as much as those two. And I don't want to dig. Like, I'm gonna fill my head with a bunch of fucking knowledge that, like, I'm not gonna waste that shit on a normie. Like, you might, it would be like 1 in 1,000 fucking globies that you even be able to get into it at that level with. Nah, they're working, dude. Colby's are just hanging back, like they're like in the bushes, waiting to see a weak ass wounded baby flat earther go by, pounce on them.
We're hiding. We're waiting.
I've got a mathematical model for Pac-Man Earth just for fun.
Oh man, that's funny. Hey, dude, listen, use it and be like, well, it works. It must be true, right? It works.
I have, and I I can share it with you. If I haven't already in DMs, let me go find out.
Oh, there's 2 flat earthers. Here they come. They're coming out. Get ready.
So it uses 4-dimensional geometry where curvature is in the W dimension. And I use a modulo function in order to express the repetition of what you experience when going across the XY flat plane.
So what do you go? I got that right. You're going in an orthogonal direction. Is that what you're saying? An orthogonal dimension? Or did I misinterpret what you said?
Yeah, you're talking about. Yeah, so it's orthogonal. So if x is the planar, like the flat dimension, x y
Yeah.
is flat. So after a
And
certain
W is
amount of x
W is
units, you
orthogonal.
go back to where you were, and after a certain amount of y units, you go back to where you were. So it's like a clock, right? You just keep going around and around and around. But the around part is in the w dimension, expressed by a radius of 3959, and this gives you your great circle route.
So, dude, that's crazy. You know why that's crazy? Because, like,
I do, because it reconciles the line of sight communications of satellites with flat Earth.
well, like in geometric algebra, right? So the horizon. So there's four dimensions, but the line,
Yeah,
but the horizon. So this is a projective geometry. The horizon is a line of infinity. So if you
yeah,
rotate an object around the line of at infinity, it acts like a translation visually, right? Like it's moving back and away from you. So it's like it's crazy that you kind of came up with that shit on your own, dude. I mean, that's
dude,
awesome.
it is a very simple formula. Let me post it for you. And it's kind of gross and not refined, but the concept is in there, and it freaking works. So you can map spherical coordinates to this in 3D. So you can map hyperspherical coordinates to this in 3D. So hold on a sec.
Well, that also reminds you like homogeneous coordinates, right? So it's 3D coordinates plus they have a fourth coordinate, right? That's orthogonal to the other three, but it tells you like the depth.
Yeah. Okay, so what this presents is a XYZ Cartesian system where in a higher dimension, the W dimension has a radius that's equidistant to every point on the XY plane that repeats itself in X and Y.
Damn.
Yeah, hold on here 1 second. Shane's giving me the big eyeballs. Shane, I've shared this like a year ago. let me go find this. Hold on a second. Oh, and by the way, this is exactly how I think ECEF works mathematically. Hold on.
I think you got it, man. You finally figured it out.
Dude, it probably does because you have the tangent plane, right? And then that other axis is basically it doesn't really exist like on the plane. It's like some other dimensional quantity.
Yeah, so this is what bothered me. There are like two vertical dimensions, right? There's the if you call Z the vertical dimension and XYZ, you've got that's going out to the stars, but you also have the radius, which is a vertical dimension from a sphere, and it aligns with the Z dimension, and you can call the radius W. So you almost have two radii, but the radius, but they line up, right? So and they line up in four spatial dimensions. Hang on just a sec. I can't believe that. So I've got this saved in Obsidian. I'm typing like the formula in, and it's not showing up. Give me just a second. Hold on.
What's your guys' opinion on Satan? You think Satan's the reason?
Satan?
Yeah, do you think Satan's the reason they saw the 24-hour sun?
Dude, you channeling the church lady, bro?
No, it's a theory I heard.
You know who the church lady is? There's a skit on Saturday Night Live by Dana Carvey.
Isn't that special?
Yeah, dude. We're not cheering on Satan here.
All right, so
The Great Deceiver.
We're good
The
on
Great Deceiver, dude.
No, I heard a guy say that Satan's the reason that they seen the 24-hour sun. I thought that was a little crazy.
Oh, what?
Yeah, some pastor, he's a pastor, and he's saying that only Satan can make a what do you call it, a mirage or a
I doubt what you're saying, dude. You got a link?
Oh yeah, I'll get a link. Hold on.
Is it Dean Odo or something? I'm not into the fucking evangelical Christian side of flat Earth.
Okay, here it is. So that there is the expression. So the W dimension is the radius of a hypersphere.
Yeah.
Zero means the point of origin is zero. So this W dimension extends to infinity. And it scales up the hypersphere through infinity. And this means in the XYZ dimension and 3 spatial dimensions, you're going to experience a case where you can ascend vertically into infinity, but the XY plane will repeat itself after 24,900 miles approximately, if Earth is a sphere with a radius of 3959. So if you set the radius of this hypersphere to 3959, you'll have the Great Circle route and 24,900 miles approximately.
You could even turn.
It will appear flat.
Yeah. So you said it'll repeat itself every 24,000 miles. That's the circumference, right?
Yeah. So it's due to the modulo. So if you set the modulo like the radius of 3959, then you will get a circumference of 24,900 or so.
Okay. Yeah, you could fucking do that by angle too, right? So you can do a bunch of shit with that.
You can do cell nav on a fucking globe with that on flat Earth. Yep.
That actually looks simpler. Quite honestly, it's just simple algebra, right? So
it is. I spent a fucking year or so on this, and I've been talking about it for almost a year, kind of privately. This is maybe the first time I've come out in public. This has only been in DMs that I've shared this before. So, yeah, thank you, alcohol. I'm like 3 drinks in right now. This is what you get.
This is top secret flurf information. I'm writing it down.
Yeah, that's right. Top secret flurf.
They built the pyramids on alcohol, man. Can't be all wrong.
No. Oh yeah, but I wasn't wrecked when I came up with this. Like I was studying ECEF and I was reading about projected geometry, and I took what I knew from call it a prior life about modulo, the modulo function in cryptography, and I'm like, fuck, you can basically think of a clock as like Earth. And the more you wrap around the yarn, you come back to where you are. It's really not that complicated. You're using remainders and division.
You know, if you were a Glober, you know what you would do? You'd claim there actually is a 4th dimension. And that because the model works, there has to be a 4th dimension. And you go out and you navigate using your formula, and then you're like, yes, it worked. So there's a 4th dimensional fucking circle somewhere.
I know. I can plot any XYZ with relation to XYZW in this. Yep. And it's going to preserve all the proportions. Whether you're like taking angle of elevation measurements to satellites, azimuthal angles to freaking lighthouses from your heading. I mean, this freaking works on a globe. It's immutable. This is absolutely locked in. And you know what? This is And when I say this is how ECEF works, it's because it's true. Because in ECEF, there are two components, right? You've got the spherical geometry of the presumed globe in WGS 84, and then you have the local tangent plane, like a fucking, I don't know, square pancake on top of the globe with east-north up or east-north down. So how do you reconcile the two? This is the model that does it. And it's as simple as I can make it. It's using algebra. I don't need calculus. I don't need to do integrals. I don't need to do like 3 integrals representing X, Y, and Z. You know? I can use simple Cartesian coordinates. Yeah, so there's my fucking flat Earth model. It explains the 24-hour Antarctic sun. It explains why you can see the Southern Cross below Sigma Octantis from Tasmania, while the Southern Cross is directly above you in Chile. You know, it's a flat Pac-Man Earth model that can use any dimension of the globe. You can program it to how you want. 3959 miles, there you go. It scales and preserves proportions. And we can invoke fucking Einstein's relativity for all the Lorentz contractions we need in order to make sure the speed of light remains invariant across reference frames. So give a flat earther a little bit of Einstein and a little bit of, you know, higher math. Like this is maybe, I don't know, 11th grade mathematics, and we can freaking debunk the globe and make an affirming the consequent formal logical fallacy and show you how fucking stupid the globe is.
Yeah, I mean, I don't think Globers ever. They're always asking us for a replacement, like as if we can't. We can do the exact same fallacious reasoning they did and construct a whole narrative of bullshit just like they do.
Exactly.
Yeah, here it is.
It doesn't need to be proven, right? All it needs to do is meet 2 criteria. It needs to be mathematically sound and explain observations. Yep. That's it.
Just has to be consistent. Just consistent. Indio, you and I were talking about manifold geometry a couple months ago. I don't know if you remember. It was late in the evening on the East Coast. And you're like, holy crap, my mind is blown, dude. Well, this is from that.
I don't like
our conversation stemmed from this equation that I've been kind of shopping around privately.
Yeah, dude. I'm actually kind of pissed off that I didn't think of it first. Dude, it's like obvious. It's like one of those things where you see it and you go, fuck, dude, that was obvious. Like,
yeah. You know, Indio, that's why you were with Northrop Grumman. I was with Lockheed Martin.
I fucking hated that job. I hate to tell you. No, I was at General Dynamics. Like, I hated that fucking job.
Okay.
Mostly, I hated the people. It was one of those things.
No, I get it. 100%.
Eric, Amish, could it involve the orthograph map? You know about the orthograph?
I mean, yeah, X, Y, and Z are orthographic, and so is the W. Actually, the hyperdimension is, and you just can't conceive of it.
Yeah, this is almost like a hyperdimensional manifold, as a matter of fact, right?
It is. Absolutely is. This is a sphere in 4 spatial dimensions, not 3 spatial dimensions. This is actually a point. It can be expanded to a sphere of infinite size in 4 dimensions. It expresses that geometry.
Fuck, dude, you're gonna actually get Cobras on our side, dude. Because they're all into that 4-dimensional shit, dude. The more fucking mind-blowing it is, the more they like it. Like, dude, we're living in a 4-dimensional hypersphere. The Earth must be flat in our 3 dimensions.
Dude, I know. I think this claim is a total load of bullshit.
Throw on a warp drive and you'll really get them.
Yeah.
We need ray guns, dude.
This is the biggest BS I've ever concocted in my entire freaking life. But it works. And this works so beautifully, I can cram any Glober claim into it and freaking hit the win button. Because you know how it works? You know how it works? I say this works because of a Lorentz contraction and expansion in force space due to general relativity. And I win.
Well, we could take this farther, right? You could actually incorporate some physics into this four-dimensional space, right? And we could say like we're only perceiving our three-dimensional reality. We're three-dimensional beings, and like we're actually in a four-dimensional space. So the four-dimensional sphere is passing through a three-dimensional reality, and we're just seeing the projection of the 4D sphere in 3D space, and that's where we are. And all the physics are happening in this fourth dimension, and we just see the effects, like things falling and shit like that. We can construct a whole bullshit fucking narrative off of this.
Yeah. So, Indio, you know why this might not be BS? Let me tell you what. What if the celestial sphere is 4D and we are projecting that into 3D in XYZ Cartesian using a mathematical expression like the one I provided?
Well,
Okay,
yeah,
all right.
go ahead, Tito.
I gotta go. I gotta go. Sorry, guys.
Are you gonna leave us hanging, you motherfucker?
Yeah. I had questions.
Dude, he's now like cocky. He's like, I gotta drop this arm. I'm gonna bounce.
Yeah. I was just thinking, like, does it solve or encounter the same problem?
Yeah. It takes a celestial sphere and condenses it into 3D in an XYZ Cartesian space. Thank you. You're welcome. I really have to go. I'm sorry.
No worries.
All right, man. Talk to you later.
I'm just wondering if it encounters or solves this similar problem, like problems that the current narrative has, where where they have to invent dark matter, dark energy to explain observations in the sky, etc., etc. Right? Does it solve that? Because man, you're looking at a Nobel Prize.
It actually probably could solve all that shit, quite honestly. Because you have an intrinsic 4D space. It's not a 3D space with a time dimension. It's an actual 4D space. But because we're in 3D, it's like flatlanders can't see the 3D world. We're 3D people. We can't see the 4D world because we don't have 4D eyes. So our eyes, well, I mean, maybe we do. I don't know. Maybe the 4D parts are freaking brain or our soul or whatever. But like if a 4D sphere passed through a 3D realm, what you would see is you'd see a point, and then it would grow into a sphere, and then it would shrink again. So it's actually not a 4D sphere; it's a 4D circle. So it's a 3D circle is a sphere. 4D circle is a fucking hypersphere. But his W coordinate is the circle in the orthogonal hyper dimension. In case people don't understand what orthogonal is, so you got like, if you have a 3D coordinate system, X, Y, Z, all those directions are 90 degrees from each other. Now, you can't actually visualize this, you have to imagine it. There's another dimension that's 90 degrees from all of that. And that's where the hyperspace is.
I'm having a hard time sort of like mentally visualizing that, like 90, like I get the 3D part, right? 90 degrees to each other. Then how is like a fourth coordinate like 90 degrees to all of that? It's a struggle for me. Like if you, I guess, like he's talking about, like if you looked at all those three dimensions collectively, and then there's this fourth thing that is 90 degrees to that as a collective.
Well, it can't be visualized. That's the thing. You can't like imagine it, like because you're imagining it in visual space, like the visual space that you see things in. Can't imagine it in that. It can't exist there. It can only exist like mathematically.
Right. Okay.
And for us, right? So you could say that the mind or something we could actually, part of our mind could be in a fourth dimension, but like We don't have like the organs, right? We don't have 4D organs. You would need a 4D organ to perceive 4D space, right? We don't have 4D eyes or some 4D sense.
Shit, man, I think Speculation Sunday started early.
Yeah, no doubt, right?
Meanwhile, there's a fourth dimensional being hearing me right now going, "You stupid three-dimensional primitive, you know, you don't understand."
I mean, the Bizarro thing, right? A Glober, because it leads to flat Earth, it would be like, that 4D shit, that's a bunch of garbage. But I'll take 32-dimensional string theory, no problem.
Right? Yeah. They drool over Michio Kaku's book and then like spit on someone like this. Yeah.
Well, this paradox has kind of like been bothering me. Like, the Glovers will say, well, a sphere of infinite radius is flat, and then they assume that the celestial sphere is an infinite radius. So when we look up, we see a flat sphere, and then like all the coordinates, right? If the Earth's a globe, like the inner sphere should match the inner sphere that's curved should match the outer sphere that's not curved. That's like a paradox, dude.
Anybody want to ask a globe or anything without getting crazy? Just normal questions and see if I can answer anything.
Are you a glober?
Yeah, I'm a glober.
What would falsify the globe for you?
To go up in high elevation and look down and see a flat plane surrounded by an ice wall.
High elevation, you mean like the top of a mountain?
I'm talking about go up as high as I gotta go from the North Pole. I go to the North Pole of the map. I increase my elevation to a height which I don't know, and no one knows really because we don't know how high you got to be to see it. So I want to increase my elevation and look down bird's eye view at the flat plane and be able to see the Earth with all the continents laid out and some kind of barrier holding the water in. Whether it be an ice wall or any kind of wall or whatever, you can have a snow wall, just magic or firmament. I don't give a fuck.
You realize we have perspective and we can only see so far, right?
No, I'm saying if I was to rise from the North Pole and go keep going high as I can go until I could look down and the thing I'm looking at would be tiny because we all agree that things in the distance get smaller or whatever. You'd be able to look down and there would be no curve in it. It's a flat surface. I'm looking down on a flat surface and see the whole surface. That doesn't make any sense.
Do you think that you have a feasible standard of evidence in regards to that?
Well, that was just one of them. That's a good one. Let's see. What would make me determined to be a flat earther? I've asked myself this question many times because I am a natural born conspiracy theorist. Let's see. Hold on. I'll mute my mic for a second. Let me think.
When you're done, do you have any new garage experiments?
Yeah, actually, I did one a couple days ago on Bro Sanchez's show live.
Cool. If you're ready to show it, I'm sure people will be interested.
Oh, yeah. I'm sorry about that one. I do my shit spur of the moment, and my garage is my gym. I had a whole bunch of these planets set up to demonstrate the February 28th solar alignment of the planets. We can all see them in our horizon. But that's gone. I took it down. So
how's that possible?
Pretty wild, huh?
No, how's it possible?
I'll post a picture in chat.
No, like how's it possible and they're still on the same orbital plane? It's not possible. The horizon dips, right?
Well, you can see them. They're above the horizon. I just posted a picture in chat. We like imagine we're all in the same lines that we have our set out lines of supposedly path of orbit, we supposedly have whatever. If the Earth is still on the other side of the track and it's looking across on the horizon, above the horizon, you should be able to see all the other runners. That's the same type of perception that you're going to get by looking across out into the sky above the horizon. The planets are going to align in kind of a slight curve, and you're going to see 7 of them or 6 of them.
Yeah, dude, but if they're at the same angle above the horizon, okay, they can't be on the same orbital plane. They'll be on your visual plane, which will be different.
Exactly. Yeah, they're not on the same orbital plane. Yeah, they're all on their own paths, their own plane. They just appear, by happenstance, that when they all in their path, they line up perfectly. So it's not like a straight line. It looks like a curve on the horizon. Like, I think Mars is the one on the left that starts, and that's kind of like, right above the horizon. It looks like when the moon starts coming out, it's kind of low, and then it gets higher. Like Uranus is high, and then Mercury and Venus and Saturn, or whatever, or something like that. Or not Mercury, Venus and Saturn are over here on the right.
See, the problem with your little racetrack thing, the problem is that A, it's flat, so that's a problem. Number 2 is the dots are different distances.
Yeah. It's just it's a quick representation of that, because he was arguing like, how can the Earth be the 3rd planet from the sun, but yet see all the other planets in front of it? And I said, well, it's kind of like perspective. If you ever have, I like to find a circle track, find one, but if you're running on a circle track, remember all the planets don't run in the same path. Supposedly, I was gonna say supposedly, they don't all have the same orbit. So some of them are irregular, some of them go out far, come back. They're not perfect circles. You know what I'm saying? It's not like everything's set up like perfect circles and they're this far apart. So the orbits, when everything's moving, and we line up with that, like we're spinning supposedly, we line up with them, we'll be able to see these things in our night sky. And I mean, I don't even think that proves anything. I just think we was arguing about it because he said, and he was actually saying that proves flat Earth, and he was saying that's not really what he calls an alignment. He thinks alignment means that a single file line, like all the planets should be seen in a straight line. And I was like, no, it's not that kind of alignment. This is just a alignment of the stars in the night sky to see them all at one time. It was a big argument. No, I think I come to the point, man. Like, you think you guys broke me like a horse, because no one's ever gonna prove anything to anybody. You know what I'm saying? All we can do is converse about it, and no point of getting all excited and emotional, because you're not gonna just yell at somebody and have, oh shit, you're Rob, I'm gonna yell.
Well, I don't understand why you guys, you're like, oh, it would falsify it looking at it. I don't get that one. Just simply looking at it. Oh, if I looked at it and it looked like this, then, it would falsify it because I expect it to look like that. When looking is subjective, and it depends on the orientation and all that shit, right? When we can know with certainty that you can just measure it, because a flat Earth and a ball have 2 different properties, surface properties. One's curving, one's not. Just simply measure that. You don't have to rely on looking at it. That's why we use tape measures and shit, because looking at pieces and parts to build a house and trying to assemble the house by just looking at the pieces, that's a recipe for disaster.
I mean, like, what Lego fanatic's not going to look at the instructions? Just pour the fucking pieces in front of them and say, build it. Like, I'm sure you could do it. I mean, but it's like...
Well, I mean, if you had the house, and the house was like engineered so that all the lumber just fits into place as bought, right? So the walls are like, you buy a 10-foot piece of lumber and it goes in the 10-foot spot, and you didn't have to cut anything, right? And that might work, because you could just do that by trial and error, right? This piece fits, this piece doesn't fit, right? You can do it that way. But like, We actually, we don't build dimensions to like the dimensionality of the lumber. We have to cut the pieces, and you can't eyeball it. Eyeballing it doesn't tell you what it is.
Yeah, unfortunately, we weren't like born like with little crosshairs and digits around the outside of our vision, all that shit, right? Like
Kind of like the Terminator, right? Like the Terminator's running down the alley, and he's like freaking calculating the fucking how far away they are.
Right? Yeah. He's got his own built-in fucking parallax algorithms and shit, right? Yeah.
Humans are.
I mean, the big clue. Well, think about the big clue should be like the self-driving cars, and like they have to put so many sensors, different types of sensors, on the self-driving cars to even know where shit is in 3D space. So I don't know if you've seen the recent NVIDIA presentation of so they're doing something like where, so say you have a factory, they have AI figures out the dimensions of the factory through cameras and sensors and LiDAR and a bunch of crap. And then they take that and then they make a digital twin of that 3D space. They make it into a 3D space, computerized, and they manipulate everything in there, and then output the output what they had to do in the digital twin, and they output that to the real world to manipulate stuff in the real world. But it takes shit tons of sensors. It's like, guys just pretend it's so straightforward. It's not, dude. It's shit's fairly complicated.
Mm. Yeah. Yeah,
it is a good point, like you make, about what things look like, because they like we'll say go outside, it looks flat. Oh, just because it looks flat doesn't mean it is flat, right? But then they don't apply that standard to anything else. It's like, well, the moon's a sphere because it looks round. Oh, the ship's definitely being obstructed from view because it looks like that. All these other things.
It looks like a celestial sphere, therefore it is a sphere. Like, therefore we're a sphere. They even take another leap.
Right. Yeah. Continue it on down the path, yeah. But that first thing that you observe and experience, just ignore that part. Right.
Yeah, ignore the one with the least amount of assumptions, right?
Yeah, exactly. Yep.
Some people are like, the moon looks like a sphere. I'm like, yeah, kind of. Some properties you look at look like a sphere, but other parts don't look like a sphere. It depends on like what you focus on. The shadow really doesn't, what they say is a shadow. The phases, they don't really look like a sphere that I've ever seen. I've never seen. And they make like a little model. I'm actually gonna post a picture in chat because I haven't posted this in a long time. So they make like a little model that you can buy like a toy, and to make the phases look like the moon phases, because that's what it does, right? It matches. It's like a moon phase clock, but it's actually like a model of the moon, like a physical sphere model, and then they have a light that lights up the side of the moon that the phases will be happening on. To get it to even project right, they have to use like a light array that's like a ring. They have to use a ring light, not like a ring light that they use, streamers use. It's like a ring of LED lights.
What the hell are you talking about?
A ring light? A ring. I'm talking about a little model. Hold on. So that's how Kubrick got parallel rays when he made The Shining. He used an array of lights.
Why did he have to do that? Why did he want that?
Because he wanted So The Shining, the hotel, it's not actually a hotel. It's inside of a soundstage where they build a set. But he wanted the lighting to be similar to what it appears to be in the winter at high altitude, right? Because the fictitious location is a hotel in the Rockies in Denver in the winter. So at that time of year, right, the sun is low. They're at high altitude, so you know what I mean. The air is clear, crisp and clear. It's not hazy. So he wanted the light that came in through the windows to look like what it would look like at high altitude in the Rockies in the winter.
Would an audience have even fucking taken any notice? I mean, like some maybe.
He's a freak, dude. Like the reason I know about it is because there's a documentary, like one of his assistants, his cinematography assistants, is like going through all the crap that he went through just to make that. He's like, he said Kubrick, that people underappreciated, was like an expert in lighting and cameras. Like that was like, he was a great director and all those things. But he said really what he was a great expert at was how lighting looked. So he wanted to imitate this effect, and this is what he did. He did, like outside. I'll actually post a picture of The Shining, from The Shining, dude.
He would have made Neil deGrasse Tyson very happy.
If the world is flat, how are they keeping us in boundary? You know, because like anywhere you go from the North Pole, you know, you just keep going. You're gonna run into a boundary of some sort, right? I mean, I don't get that.
So what? Who does that?
Well, you're kept in a boundary by being told it's a globe.
What civilians are out there going, I'm just going wherever the fuck I want?
Yeah, nobody.
Okay, so we're trapped in our minds.
If you wanted to go somewhere, you would just go to one like of the known places, you know. You wouldn't just set out and just start freely, independently exploring, you know.
Yeah, I wouldn't. That's for sure.
Not really anybody would, because... Yeah, go ahead.
I was just going to say it's a little bit like the Truman Show. Like they're just telling everyone, well, there's nothing to explore. We've already explored everywhere. This is just a little continent of ice. It's terrible there. Don't worry about it.
No, go to Amazonia and try to explore. Go to any desert and try to explore.
I don't know if any of you saw, but there was while the final experiment was going on, there was also like a Marine supposedly trekking across the entire Antarctic.
Yeah. Did you see his? He's still there. He's still doing it. I looked right into that. I was kind of excited. I was going to track his trip. I was like, wow, this is pretty cool. Right? He raised over $1 million. He made videos showing how much everything costs, right, just to drag a sled across Antarctica. Then if you look at his planned path, right, it's pretty pathetic. I mean, in regards to not working at proving a globe or anything like that, it's just... I'll post, I have a screenshot here of his post path. He said it cost him 60 grand. Him and his equipment get a flight to Antarctica, and then he had to get another plane when he was in Antarctica to his somewhere like his starting location or something like that. And apparently that plane trip cost $250,000. And then it cost hundreds of thousands of dollars in like part of his permit to be able to do this. He had to have like all sorts of like medical teams on standby. Right, so I think just the basics of the trip, right? The basic costs. He said they cost like $750,000. So Pace says in the chat that explains nothing. I'm scrambling. Didn't make any claims, man. I'm just telling you what this dude's said and what he's doing. Didn't make any claims at all.
Man, all that money just to drag a sled across the ice? Jeez.
Yeah, man. Yeah, like this guy, if you check his Instagram, right, he did some previous crazy snow treks, right, and he had to cut his own fingers off because he got like frostbite. So he's missing like a finger, and yeah, he just does like crazy stuff like this. He goes on like motivational podcasts and stuff. He seems pretty legit. Yeah, sounds like a horrible journey. But yeah, if you check his
Colin Brady.
No, he's got a funny name. Let me check exactly what it is. I think he's an ex Marine or Navy SEAL or something like that. I'm going to post his website. Well, it says the first ever solo coast-to-coast ski crossing of Antarctica. Akshay Navati. He's being tracked, and he leaves like sound bites, like he tells you how the trip's going and what it's like and stuff. His website's there in the side chat. Yeah, if you go to his Instagram, yeah, he's got videos explaining like how much things cost and that sort of thing.
Man, it kind of seems like a missed opportunity. Like if you're gonna do that, you got at least some mush dogs, like the team of what is it, Huskies they use.
And they do that in Antarctica.
How did he navigate? How did he know where he was?
I have no idea, to be honest.
Neither does anybody else. So this guy Colin Brady, he said he did a trans-Antarctica crossing, and he said his GPS stopped working, and then he navigated by compass, which is freaking impossible. It's actually impossible in Antarctica to navigate by compass because the compass won't stop spinning.
Is that like a debated fact, or is that or is this from the Admiral Byrd?
You can go on YouTube and watch it. Type in, do compasses work in Antarctica? Because the magnetic south, there's actually two magnetic south in Antarctica, according to the Golders.
But maybe he had a gyro compass.
Yeah, you solved the mystery. He had a gyro compass. That's it.
Yeah, I've heard magnets compasses act funny the further south you go. I don't know why that would be though.
Yeah, they only really work well pretty much Western Europe and North America. There's magnetic declination like everywhere else, so they're a little off. But in the south, they're way off. It's just crazy. Magnetic south is supposed to be in the Southern Ocean. It's not even on the land.
Well, maybe that guy's using a satellite, like a GPS.
Apparently, there's no coverage.
Yeah, he said his GPS stopped working. And he ripped out the compass. But some people like to look at the magnetic poles as the reverse. So it's like, and your north needle is actually pointing towards magnetic south. So magnetic south is offset from geographical north and vice versa. That's the literature says that. Like, you can technically look at it that way. Right.
So you can't navigate by stars because it's daylight all the time. Can't navigate by landmarks because it's one giant ice sheet. Can't navigate by compass because it don't work. Can't navigate by GPS because GPS doesn't work where they claim they were. GPS only, like, if you have a satellite directly above you, the circle that's supposed to work is like 273 miles. So that ain't gonna work. Or no, sorry, that's not GPS. That's like Starlink. Starlink doesn't work.
Could you navigate
So
by the sun?
I mean, yeah, I guess maybe that might work.
Oh, well, what if it's 24 hours, son? Like, I mean... well, you got no fucking idea which direction is which, right?
Just run away from the guns. Wherever the guns are, just run the other way. You know you're going in the right direction.
Yeah.
Run away from the screaming dudes. The dude screaming, "Where are the guns, dude?" Wait, like, I'm sure his voice traveled a long way on that nice flat sheet of ice.
Yeah, if you're lost in Antarctica, just start talking about flat Earth. McToon will turn up.
Yo, can you imagine, like, the people that went down there for like normal reasons, and they got this dude screaming, "Where are the guns, Nathan?" I came to Antarctica because it's the most quietest, pristine place on the earth, and we got some freaking globetrot screaming, "Where are the guns?"
Yeah. Come out of your fucking tent, you're like, shut up, dude.